So we're going to look at population change equation. And so first we're going to look at this in a general if I'm given a whole bunch of numbers about a population. So the first question, it says, what's the population change like numeric? And again, this is that idea that R, the intrinsic rate of change that happens. So population change, my births are going to cause it to go up. My deaths will cause it to go down. So I did births minus deaths, plus immigration is going to cause it to go up, and emigration is going to cause it to go down. So when I combine this, you could do this however you prefer, but I have 2,000 plus 3,000 is 5,000. And then if I take 1,500 and 1,000 and combine those, that's 2,500. So 5,000 minus 2,500 gives me this R, or this change, of 2,500. Okay, so that's just my numeric change here, or it would be really my R is 2,500. The second one, is that a big change or not? I have no idea. So that's why we'll often see population change as a percent. And so the percent is that change, so this R, this change, so that part over the total population is percent over 100. Now, I can go ahead and do all of this, or I love scientific notation. So I'm going to cross multiply, and I'm going to say 25 times 10 squared, and I'm going to divide by 5 times 10 to the fourth is percent over 100. All I did is rewrite in scientific notation. If I cross multiply now, I get 25 times 10 to the fourth equals 5 times 10 to the fourth. I'm going to change my percent sign just to an X because we're more familiar with that. To solve for X, I divide both sides by 5 times 10 to the fourth. 10 to the fourth divided by 10 to the fourth cancels out. 25 divided by 5 is 5. So my population growth rate is, or population change in percent is 5%. That's pretty big. That's a pretty rapid change. So next I want to calculate my doubling time. Doubling time uses the rule of 70. 70 divided by the population change rate in percent. And I leave it as a percent. I don't make it a decimal. Gives me the doubling time. So I'm going to take 70 divided by 5. And that's going to give me the doubling time. So I put 5 on the outside, 70 here. 5 goes into 7 one time. Subtract 2, bring my 0 down. 5 goes into 24 times. So my doubling time is going to be 14 years. So here I can take this information, I can find a numeric population change, I can find the population change in percent, and then I remember you need to just know this equation for doubling time. I can find the doubling time. Now, demographers, people who study population change, will often talk about the crude birth and crude death rate. Why? I have no idea, but this is how they talk about it. And typically the crude birth and crude death rate, crude means out of 1,000. So how many births are happening out of 1,000? Well, I can look at the raw data up here, and I know there's 2,000 births out of 50,000 people. So how many births would that be out of 1,000? It's my exact same setup. So I'm going to do my births out of my population, and I'm solving for my crude birth rate is out of 1,000. It's the exact same setup as percent. The births over the total is what the percent, the crude birth out of 1,000. The only difference is crude means out of 1,000. Otherwise, I can use the exact same setup I use for percent. When I cross multiply here, and I'm going to do it I'm going to rewrite in scientific notation, 2 times 10 to the third over 5 times 10 to the fourth, crude birth, 10 to the third. So I'm going to get 2 times 10 to the sixth divided by 5 times 10 to the fourth, 2/5. Oop, this is a good time to remember my fractions. 1/5, if you'll remember, or if you don't, you should, is 0.2. So 2/5 is 0.4. So I get 0.4 times 10 squared, What does that mean? Move the decimal 2 places. And so I'm going to get 1, 2 places, 40. So my crude birth rate here is going to be 40. Take a moment, try, kind of pause this video and try to do the setup for the crude death rate. So for the crude death rate, again, I would encourage you to pause the video and see if you get my answer. I'm going to go ahead and do the crude death rate. So I'm going to do here. And I got a crude death rate of 30. So again, I did it all in scientific notation because you know I love scientific notation. Lastly, on here I talked about the natural population change. Natural just means births and deaths. So natural population change, I'm going to take births minus deaths. It's not asking me a percent. So births minus deaths is just going to be 500. So my natural population change would just be 500. Let's do a percent just for more practice. So for a percent, my natural population change in percent, I would take that population change here, 500 over the total population is percent over 100. Again, as I can do my cross multiplying, and I love things in scientific notation, over 5 times 10 to the 4th is percent, 5 divided by 5, so I get 1%. Why does that matter, or why is that significant? Well, in some regards, what that shows me, I'm sorry, that kind of went off the edge of the page there. What that shows me is 1% is natural from births and deaths. Where is most, or what is causing most of this population to change is the immigration. Okay, much more of the population is changing due to immigration rather than due to the natural changes like the birth rate. So again, those are things that can tell you something about what's going on in a country. Lastly, it says if you're told this society was in a state of ZPG, again, ZPG is zero population growth and its emigration rate is unknown, what would the emigration rate be to maintain the state of ZPG? So I would have births minus deaths plus immigrants minus emigrants has to be 0. So what must that be? 5,000 minus 1,500 equals E. You'll notice I just did a little bit of algebra there. So E would be 3,500. So those are all different with the terms and things that we could use.